Have you seen these equations in physics? Yes, you probably have, but please do not memorize these equations. You do not have to, because this is just basically right triangle trigonometry, okay? There's nothing you need to memorize in there. I'm going to show you the entire reasoning and derivation of these equations, okay? So I'm going to give you an example. We're not going to go into any numbers just yet. So let's say we have a vector, which is going to be, let's say something like this. We're going to have this. Now, you know this vector is going to have two components. A x component, which let's say is going to be something like this, and a y component, which is going to be something like this, okay? Now remember that these two components, we're going to call them Vx, or well, any letter that you're using to represent the vector x, and Vy, okay? Let's say the vector we have is going to be V. And now the hypotenuse, because this is a right triangle, we can call it a hypotenuse. This hypotenuse that we have right there is going to be the magnitude of the vector. Remember, the length of the line is going to be the magnitude of the given vector. Now, how do we derive all the equations that we had before? Well, something we can do is the following. Let's say, for example, that, let's say we have theta right here. So now, for example, what if we wanted to find Vy, and I'm actually going to give you this, okay? Let's say we have this right triangle, which is basically the same thing. I'm going to say this is V, this is A, and this is H, okay? And this is theta. What if we wanted to find for this triangle right there, B? Well, you have a lot of things you could do. For example, you could use the Pythagorean theorem and solve for V. Or if you want to use a trigonometric function, let's use, for example, tangent. You could use tangent of theta is going to be equal to V over A. Remember, it's opposite over adjacent. So you could say V is equal to A times tangent of theta, okay? Now, what if you wanted to use another function? Well, you could use, for example, sine. You could say sine of theta is going to be equal to the opposite side, which is V, over the hypotenuse, which is H, which means that V is equal to H times sine of theta, okay? Now, these are two ways in which you can compute B. Now, if we know B, you see the resemblance right here. B is equal to Vy. So let's do the same thing for Vy. So for example, for this, in this triangle, we would have that Vy. We could find that as, now let's say tangent of theta is going to be equal to Vy over Vx. And you could find Vy by multiplying Vx on this side, okay? Which is the same as if we multiplied A on this side. So we're going to have Vx times tangent of theta. Okay, that's an A, yeah. Vx times tangent of theta. And now, what if you wanted to use sine of theta? Well, then what you could say is that sine of theta is equal to the opposite side, which is Vy, over the hypotenuse, which in this case is the magnitude of the vector. And now how do you, well, now you need to solve for Vy. So you're going to have that Vy is equal to magnitude of the vector times sine of theta. And this is the sweet equation that you have memorized, okay? This equation is absolutely the same thing as this. You have a right triangle which has side A and B, and you need to find A, you need to find B. Well, you just simply rearrange everything. And this is the same reasoning here. You have side Vy, side Vx, this is your vector, and well, now you can just simply say that sine of theta is going to be equal to the opposite side, y component, divided the vector magnitude, which is going to be this number. And then you multiply this number on this side, and you get Vy. It's that simple, okay? Now, this is one equation that you know, okay? It's one equation. I'm going to close it in there. Now, let's go with the other one. For example, what about Vx? Well, it's the same idea as if we found here, as if we try to find here, for example, A. So if we wanted to find A, what could we do? Well, you could, once again, you could use tangent. So you could say that tangent of theta That's A. Tangent of theta is going to be equal to V over A, right? And we need to find A, so we're going to have that A is equal to V over tangent of theta, okay? This is just basically normal algebra. You move this, then you divide by tangent theta, and you're good to go. You find A, okay? You could also use cosine of theta. You could say that cosine of theta, that's an S. Yeah, I know it looks like an O, but yeah, that's an S. We do this. Cosine of theta is going to be equal to the adjacent side, which is A, over the hypotenuse. And if you wanted to find A, well, then you would just get A is equal to H times cosine theta, okay? And now in this case, well, if we wanted to find, for this triangle right there, if we wanted to find Vx, our x component, it's going to be the same reasoning. So let's use cosine of theta. Cosine of theta is going to be equal to the adjacent side, Vx, over the hypotenuse, which is the vector magnitude. And now, how do you find Vx? We'll just multiply by the vector magnitude on cosine of theta. And you have vector magnitude times cosine of theta. And this is the other famous equation that you have memorized. There is no need to memorize this because this is just basically trigonometric functions, okay? This is like the more baby notation. This is like the more physics notation. And basically, I'm just really giving you the baby notation so you see that this is very simple. And if this is very simple, then you do not need to memorize the physics notation part. Because although this is physics, it's absolutely the same thing as this. Okay, and this is another equation that you have. Now we're still missing one equation, which is an equation for theta. How do we find theta in this case? Well, if for this triangle, let's see it. So remember that there are inverse trigonometric functions. So for example, if you say that you have tangent of theta is going to be equal to b over a, this is going to be equal to a number. Now, there is something pretty cool. If you want to find what value of theta is going to give me this number, then you can use the inverse tangent function, which we call it arctangent. That looks like an N, but it's supposed to be an N. Arctangent of that number. So you're squishing that number in there. I'm going to say num, and this should be equal to theta. Okay? I hope I'm assuming you already know what these inverse trigonometric functions are. If you have theta and there is a specific number for theta that if you plug it in, you're gonna get number. Now, if you wanna see what number is theta, then you need to take the inverse function, which is arctangent. So you put number for arctangent, and then you're gonna get back theta. Okay? What number of theta is gonna give me number? You do that with arctangent. Now, why is this important? Well, in this case, we just found theta for this triangle sort of like that. Because if we plug in number here, and we know number is equal to b over a, remember this is just logic in equations, if this thing is equal to this thing, that means that we can write arctangent is equal to whatever this thing is equal to, which is equal to v over a, okay? And this is equal to theta. Now, if we wanted to bring this notation to the physics side, well, how can we do that? Well, let's try it like this. So, if we have that theta, no, actually, let's go all the way to tangent. So, if we have that tangent of theta is equal to our Vy over Vx, and we wanted to find theta, and let's say this is going to give us, remember, this fraction is going to give us any number, same way v over a gave us number. Vy over Vx is going to give us another number. So if we do that, if we do arctangent of whatever this number is, which you could say is Vy over Vx, okay, this is going to be equal to any number. And if that number, we plug it in there, we're going to get theta. And that number is equal to Vy over Vx, so that means that we can plug in Vy over Dx. They're the same thing. So Vy over Vx is going to be equal to theta. Now this equation right there is absolutely the same as this equation right there, okay? And this is one of the famous equations that you have memorized too. And also, one way you could also write this equation is as this. Theta is equal to arctangent of tangent of theta, okay? And that's equal to theta, basically. Because how much is tangent of theta is equal to Vy over Vx. So that means that you can, instead of plugging in Vy over Vx, you can plug in tangent of theta, okay? And that's going to give you simply the input for tangent, because arctangent and tangent are going to kill each other, and you're going to get back tangent. That is how it goes. Now, these are the three famous equations that you have memorized. Please don't do that. All these equations are just trigonometry and Pythagorean theorem. So, well, I hope you understood all of this. I hope you enjoyed this video, and see you in the following video. Bye.